Test, test. So good. So, hi everyone. We are starting. Please take your seats, grab a drink. And we have also people online, by the way, today. So, hi everyone who's joined us online. And feel free also to post any comments and questions online, and we will check it. We will moderate that. So, you are also part of the event. Yeah. Uh, just a few thoughts from my side. But of course, I would like first to thank our supporters. And we have two supporters today. We have our long-time friend, SAS team. Unfortunately, I think no one is here today from their team, but they're really cool guys and supporting us for a long time. I think third year already. We have today also guys from the UMETSAT who are supporting us with the content, with the speakers. Um, yeah, so thanks for this kind of support. A few thoughts from my side. So when I was like organizing this event, I was not really like sure, and I had this kind of feeling that I'm doing it for the first time. Because when we did it for the first time, we had it like in a bar. Like I think there was 5 people, including us, so 2 people basically show up, and we didn't really expect more than this. And the topic, the interest to the topic was really growing, and we have more and more people. And our last event, I think it was more than 1 year ago. It was also here, and we managed to do that in between this break between the lockdowns. And before that, it was also I think in February or March. So it's really like a long time. So I kind of have this feeling that it's for the first time, and I had also no idea how many people will come, because not that many people basically registered. But I think the no-show rate is really low this time. And I also see a lot of people whom I know personally who are visiting our Frankfurt data science events, and that was for me the most important. Basically, the quantity doesn't matter; it's basically the people. Yeah. And right now, I would like also to introduce and thank Dr. Sebastian Schäffer, the managing director of the Tech Quartier, who are kindly hosting us here. So, Sebastian.
Thank you, Elda. It's really a pleasure to have you here. Elda is always not only a good member, but also a good friend, supporting a lot TQ and our project. So very happy to have you. And it's really not that we're closed, yeah, for the last 2 years, but of course there were fewer people, and that's why we think it's super, yeah, that the frequency of visitors, that the liveliness is picking up again. Very happy about that one. Over the last 2 years, we were quite active in pushing projects, in growing our community. I don't know if you know, but over the last 12 months, we grew our community by roughly 60%. We have now 480, 490 startups, not all of them here in Frankfurt, not all of them here on site, but growing number that is connected to us from Germany and beyond. I think that's important that you also know this. And we were engaged in starting a couple of projects, and one of them is also quite fitting to your topic around data science, together with a big consortium of other corporates, but also universities and startups. We are working on topics like anti-money laundering or sustainable finance, to understand how we can deploy actually machine learning and AI techniques to solve really pressing problems. For that, also TQ is ramping up, and I want to take the opportunity to let you know if you're interested in learning a little more about the various projects, maybe being interested in even engaging, feel free to look at our job board, look at our website and the news around it. Would be happy to have discussions. I think there's a lot of interesting stuff happening, and people with your interest and your skills could be a wonderful fit. Ada, I wish you and all of you a wonderful discussion, wonderful evening. Enjoy the networking, and hope to see you soon. Thanks.
Thanks, Sebastian. By the way, there is an interesting fact. I work also from here, so I have a fast desk here. And I know that there are already, I think 3 or 4 or 5 people who are basically also the backbone of the Frankfurt Data Science are also working here. So we have kind of like a embassy, the Frankfurt Data Science physical embassy here in Tech-Quartier. Okay, so and now I would like to introduce you to Mario, who is a space engineer, and it's a very interesting combination. He's a space engineer and entrepreneur, which is not really very often fits together. And he'll make a cool talk today. And Mario was already presenting once. It was quite a quick talk on topic space. And Mario is basically running the startup, which is about optimizing the marine industry, like logistics, for example, with the help of Earth observation data and machine learning. So, Mario.
Now you can hear me. Okay, thank you. Mario Castro de Lera, Spanish from origin, but European, let's say. So I'm a spacecraft operations engineer for 18 years and try to do for the last 4 years a transition to the entrepreneurships. I wanted to start my talk by bringing you something that for me is very important, is that this effort that you are going to see today is coming from the new policies for the European Commission in creating a new economy, data-driven economy in the navigation and the Earth observation data. So you have 2 big programs, the Copernicus and the Galileo programs, which are funded by the European Commission, and they are generating a lot of data, a lot of services that you can use for free. And this is what you should be interested today to acquire. That this, what we are going to speak today, is everything for free. So the first thing is, I'm going to go briefly on the data that we are using as entrepreneurships. So for the Earth observation data, we are very focused in the maritime industry, in the ocean. Then we are looking to the currents, to the winds, the waves, the sea ice, the sea surface temperature. So we are also looking not only to those meta-ocean data, but to the biological data that we can see from the satellites, the plankton or the chlorophyll. But we are enhancing, we are doing an added value to those data by using another auxiliary data. So we are going to see that we are using the ports, the AIA's data from the ships, from the routes that the ships are doing all around the ocean, the landings, the captures of the fishing industry. They are reporting these landings, and we are using this information to know where these people was fishing. We are going to see how the information on the earthquakes is important for us to being able to verify from space the tsunamis, or the kind of fishing of species that we are fishing, where these fishing species are located. And finally, we are going to talk about how we are using the little resources, implementing artificial intelligence application with the Earth observation to see where this marine litter is in the ocean. Okay, let's speak. Sorry. We need to think that this data, we have in this data historical data, and this data is coming from the 60s in some cases, and from the spacecraft point of view from the 90s. We have data already collected from satellites in orbits from the 90s. This historical data we are going to use to learn from them, okay? But we have also in situ measurements. So the satellites are doing measurements now, but we have also data that are collected on ground or on the oceans. And we are also taking advantage of this to correlate, to calibrate the data that we are acquiring for the space. And finally, we have the models, we have the data, and we are doing forecasting with this. And we are using this forecasting to predict what the conditions of the marine litter, where this is going to be in the future, okay? The first application I'm going to speak is about Poseidon. This is a route optimization for the ships. So we are using currents, waves, wind, and swell as an input. We are integrating this in a navigation algorithm with a navigation algorithm, and from there we are creating a function cost that is giving us the information about the conditions the ships were navigating and how much cost was for them when they were operating on a specific route. We are going to integrate this data with the GNSS routes, also the AIS data, and with the fuel consumption. We are learning with the historical data about how they have been operating the ships during the last years. We are going to learn, and we are going to see which are the best conditions to operate the routes, and trying to estimate where we are consuming the routes the less fuel possible. We are optimizing two variables as the fuel consumption, and we are also optimizing the time to arrival. As one of the big important variables for the shipping industry is when I'm going to arrive to my destination. Being able to determine this time of arrival is a key element, especially in those days. You probably know very well that at this moment we have a big issue in the maritime industry, specifically with a lot of shipping companies stuck in the ports. Okay, this is the first application where we were developing. The second one was taking advantage of this approach for the fishing industry. So in one side here, we were learning from the navigational historical data and the ocean data, the historical data, through a neural network in one side. And from the other side, we are selecting our destination point, looking to the species that the fishing boat wants to catch. Combining everything, we are going to give two important elements to our customers. The first is the optimized route to arrive from the destination, from the departure point, and the optimized route from the destination, the departure point, to the best location where they are going to find, they have the highest probability to find the species they are looking for. Then we are identifying the best fishing ground, and we are giving to our customer the best route to achieve this point in the quickest way. They are able to already save in operation time up to 10,000 euros per day with this kind of optimizations. Okay. Polaris is the same application, but based focus in the polar regions. In the polar regions, we have other problematic. We have the sea ice, for example, we want to know where the ice is, so in terms of accessing from the coast, but also in terms of icebergs and the movement of the iceberg. And we are integrating this to provide a safety route for our customers. So now it's not only that we are optimizing the route, but we are doing also a safety route for our customers in a very dangerous situations. And here you can see, as example, if I want to go from Aberdeen to this specific area in the north of Norway, so the red line is the shortest path. That is the path that usually every boat is operating currently. So they go straightforward there. But if you see, the blue line is going to take advantage of especially at the latest stage of the currents. This is a graphic from Windy of the currents. The currents is, for example, one of the most important contributors to the function cost of the vessels. And it's going to take advantage in the way forward from Aberdeen to this fishing ground. In the other way, when we are operating from Norway back to Aberdeen, we are interested to avoid the currents. Then we are going to go closer to the ground because typically the currents are slower in the coast, and then we are going back as quick as possible. This is here we are also integrating a lot of information, as I mentioned, of the landing captures that Norway is reporting or that Scotland is reporting. Then we know when they are reporting, we bring 10 tons of swordfish, and with the AIS data, we know that they were fishing over there. We know where the captures were done. Okay, and this we are learning for all the boats that are fishing. Okay, we are integrating this in our algorithms to do our best fishing ground identification. Another project that we have been done is one wave, the tsunami verification from space. Here we are using similar data. We are using the sea level anomaly, also let's say the difference between where the waves are and where they should be. Okay, and the satellites, Sentinel-3, for example, the satellites like Sentinel-3, they are measuring the sea surface height, and they are giving us this very quick. We are going to process this data as quick as possible, and we are going to see the signature of a potential tsunami when this is occurring. So we, of course, most of the detections are done after an earthquake is happening. Then we hope that also we are listening the earthquake detectors. Once this is happening, we are able to propagate this with models to see where we should be, where the tsunami should be with the characteristics of the earthquake, and we are going to take from the measurements of the satellites and go to verify if this was happening or not, and which is the sea service, the sea surface height at this level, and we can confirm and alert the authorities to say, okay, the tsunami that it was produced is in this point from this kind of event. Okay, and this is done with learning from past events. We have retrieved all the telemetry of the satellites from the 90s, correlated this with the different database from earthquakes, running this for a long time and trying to spot all these events from the satellites. It's not easy, and we know that we have a detection threshold of 30 centimeters for this such a event, but 30 centimeters is when you go up to above 30 centimeters, you are going to have already a big event. Then it's a good threshold. But we have other problems in the detection that we are trying to figure out with the collaboration of the Indonesian Space Agency, which was supporting our pilot for that. And finally, I would like to go quickly through our last study. This is a study that we are doing now with ESA, for ESA, to try to determine where the marine litter is now or at any time given. So up to now, the studies that has been done are more or less using only the currents and the surface current. But the dynamic of the litter is very diverse, and even the litter is very diverse, because you are going to see, you have heard about there is a lot of presence of plastic in the oceans. Yes, but most of this plastic is very small. So you don't have big uh, big amount of big sacks or these such a things. You have the amount of plastic in of this characteristic is very small with respect to the whole plastic that you have in the oceans. Then the current is only one indicative. But there is other variables that we can use now, and this is the goal. One of the goals of our study is to use also the waves and the winds to see where the litter should go. Okay. So we are doing this for the whole globe with the information that we have for the whole globe, combining all these effects. And in the other side, we are using, for the estimations, we are using all the sources that we are considering the main contributors to the litter currently. Also the coastal areas, also these locations where they have a lot of population, they are generating a lot of plastic and delivering to the oceans. We are looking to the shipping routes. So the ships are also releasing plastics during the routes through the oceans. The rivers, the big rivers, are also apporting a huge amount of debris and litters to the oceans. And finally, the fishing areas. The fishing areas, most of these of the contribution they are doing is in the gears. So they are all the nets that they are forgiving there or they are releasing there, they are contributing to the marine litter. Okay, so we are integrating this with data that is, as mentioned before, from the spacecraft from 1993 until 2018 with a very good resolution and in a global scale. And what we are doing in terms of machine learning here is we are taking the variables, we are doing a clustering with PCA key means algorithms to create patterns of the variables that are the most common patterns that you are going to, that are reflecting the variability of these variables in the ocean. The number of patterns that we are going to have is a compromise, a trade-off between the indicators of the quality of the patterns and the F-score that we are going to have with this number of patterns when we are going to do the logistic regression. Okay, then we are going to, with this data, we are going to train our model, apporting some features. The features are the climate variability that is going to give us an additional information about the behavior in the long term. We are going to simulate this and go through for the futures, we have more data. Then what we are going to do is we are going to use the data to simulating until 1979. And for there, we are going to learn, okay? And we are going to create these patterns in terms of time, environmental dynamics in time, okay? And for each instance of in time, we have a representative pattern that we are going to use to, with the inputs, propagate with a Lagrangian transport model, which is called Open Ocean Parsers, and is available for everybody that wants to play with it, to see where the litter should go, and where what we are trying to figure out is where this plastic is accumulating. Okay, to see if we can take measurements also to get rid of the plastic. Okay, so as here I have an animation to finalize, which is going to give us an idea of how this dynamic is happening in the North Atlantic area until the equator. Okay, you see that we have we are looking to the sources, the different sources. At the beginning, we have seen the ship routes as one of the start points. We have the population, and one important point that you can see is that the blue lines here is that the litter at the end is going to arrive to ground. And one of the reasons we are not seeing, we are suspecting that one of the reasons we are not seeing so much litter in the ocean is because a lot of them is coming back to us in different places. Okay, then this kind of simulations are there to see how this has been evolved. Now, one of the objectives that we have within the project from ESA, this is the sponsored by ESA, and we need to correlate that our model is in line with the measurements. And it's not easy. As you can understand, it's not easy to go to cover a realistic area here to validate the model, but there is already campaigns. We are using Sentinel-2 and Sentinel-1 to try to see if we can already measure from the space concentration. Okay. But for the moment, our model needs to be validated, but is much more accurate in certain areas that what we have up to now. Okay, and that is all from my side. I hope this can give you an idea of which are the applications that can be done with the Earth observation data, specifically in the ocean atmosphere, let's say. And I thank you, all of you, for attending the presentation. Thank you very much.
Thanks, Mario.
I hope
So
I
thanks
was
for-
good in time, more or
Cool.
less.
No, look, you were on time, really. And if there are questions in the room, so let us know. We have here a mic, but before we start questions in the room, we have a question that is coming from the YouTube. So Andreas Graf is asking, did you include in the size, did you include as a feature the size of the fish population or any other features? That was I think somewhere in the middle of your talk.
Yeah, as for Polaris, we are also including the size of the population. Yeah. So we are including different variables. One of those that we are using is the landings, but we have data coming from FAO, for example, that can help us to determine where the best areas for a specific species are.
Okay, Andreas, if you have additional questions, so just write in the chat. And there was a question in the room.
This gentleman has, and the lady.
I have a question also about the smart fishing. Maybe I missed that, but in the navigation system, do you actually tell the customer or like share a model which is more ethical to fish? For instance, how much if one species is really in danger, don't send anyone there, something like that.
Yeah. So we are integrating. There is open data on the areas that, for example, is not allowed to fish, and then these areas are even not allowed to cross with the ships. Then they are excluded, these areas, from the ship, from the route. They are excluded also for the fishing. But one of the important things here is that the, the, the fishing industry in Europe, especially in Europe, has a very restricted number of captures they can do. Then they are limited already from this point and control it strongly in the arrivals when they are arriving to the ports. Okay, we are integrating all this the non data that we have, and they also let's say the watcher here is the government for.
Hi, Mario. Thank you. On the LITER project, which is the resolution you're using for the training? So trying to make the model of the LITER distribution. And a follow-up question is, do you think there is a difference between using a flat, Cartesian model or a spherical model of the Earth? Would you have a difference? Because of the compression of the poles or stuff like that?
No, also answering first the second question, we don't see any. You have we are working all with the same projection in terms of cartographical projection. Then we haven't seen any influence from going from this to an spheric world. So I don't know if this is answering your question. And the resolution is given by the data that we have in terms of meteo-ocean conditions. That here is it depends, but the biggest resolution is which is the driver. Then this you have a third quarter of degree for that in terms of resolution.
I have a question. Yeah, first of all, it's an impressive number of use cases that you have. Thank you.
At the end, if I may, at the end, you see that we are accumulating, we are reusing the use cases or expanding the use case.
It's smart. It's smart. Well done. And my question is, how many of them are live in a sense? So I can imagine some of them are proof of concept, and some of them are already in use. So that was the question is, which of those use cases are already in use and which are still in this at the stage of proof of concept?
Okay, this one specifically is in use. So we have a pilot customer which is operating in the South America and is doing the trips from Spain, taking advantage that we are from Spain originally. So is going from Spain to the South Atlantic, fishing there, doing the landings in Montevideo and in different places in South America and in South Africa, also in the south of Africa. This case specifically is already in use. It's still in prototype, but it's already used for practically. And we have, this has been already verified. And this is why I could give this figure that the operator that was using this application is saving 10,000 euros per day of operations applying our solution.
Okay, thank you.
Hi, thank you for the interesting presentation. I was wondering what's behind the, like in terms of architecture. So what does the architecture landscape looks like? What kind of tools do you use, databases? Is it in cloud?
So our development was done mainly in Python. We are hosting all our applications in the Wikio that we have been early adopters for the very beginning. and we have developed it, for example, an API in Fast API to provide our customers with an easy solution for the routes. Yeah, so we are not providing, we necessarily, because of the logistic of the vessels, so you have a limited bandwidth to transmit information. Then we are not doing these fancy things for the ships, because they don't have the bandwidth to. What we are giving is the waypoints to go from here to there, and we are giving where the location of with a resolution or also a 10 kilometers resolution for the fishing grounds, for example. That means that we are limiting in the information that we are limited in the information we are giving. Then with the API that we have, they can just do the request and get back the information. And they use it in their own systems. The vessels, they have their own systems to use for the visualization of the routes and for the visualization of the security and so on.
So Mario, thank you very much. Thanks for coming. It was, as usual, cool talk.
Thank you.
1-1. Test. Okay. This mic, I think, is better. Okay, now I would like to invite on the stage Daniel Lee, who is a data access system operations manager and just a cool guy and also an entrepreneur. And he also did a talk, actually, I don't know, like maybe 3 years ago. It was at Frankfurt School. And sometimes that kind of talks which somehow you remember. And I think your talk was one of those that I remember, especially that fax machine in the car. So I will never forget it. Daniel, and you're going to share with us also some cool stuff, some cool content, and feel free.
Okay, thanks, Eldar. Yeah, when I arrived this afternoon, Eldar also reminded me about this famous talk from 3 years ago, which does not feel like it was 3 years ago, because I did not remember this, but he told me that I was wearing the same shirt on that day. It's coincidence. I have a very boring system in my wardrobe that makes random selections of shirts, but somehow it turned out this way. So here I am, back in the same place, wearing the same shirt, but we're talking about something different today. And I'd like to thank Mario also for plugging Wikeo, because that is the topic of my talk. And as you can see, I've not provided any slides. Instead, I'm going to do a live demo, because this is a guaranteed way to find all the bugs in our system, showing it live to a group of people. So when you're looking at these really cool use cases that Mario was showing, you have an idea, you need a lot of information about the environment. You want to somehow bring this data together and fuse it with other data from other disciplines. Then you might have the data, gee, where would I get, or the question, where would I get all of that data? And I have the answer for you. It's probably Wikeo, at least if you're interested in environmental data that is collected by the European Union in the Copernicus project. There's a ton of data there. I'm going to show it to you. And then the second question you might have would be, well, gee, where can I compute with all of that data? I want to bring my algorithms to the data rather than download it or transfer it to another cloud or something like that. It's Wikeo, spoiler. And also, if you are looking for support in accessing this data and in utilizing the data also in the cloud that's offered by Wikeo, then another thing you might want to look at is, again, Wikeo, because we also offer their technical support and scientific support in the utilization of the data there. So I think it's a really, really interesting platform for combining all kinds of environmental data, observational, model data. There's a ton of stuff there, and oftentimes the most efficient thing that you can do if you want to work with this stuff is just get your algorithms into the cloud where the data lives. And so let's try it out with a demo. I'm going to walk behind everybody and creepily talk behind you while you look over here, because this will be my screen. So imagine this is a webinar, and at the end I'll return so we can talk, answer questions, etc. Okay, so here you see Wakeo. This is the website. So if you just search for Wakeo or go to Wakeo, wekeo.eu, you'll land here. And one thing that you'll notice is I find it slightly, you're presented with a lot of options when you're looking at this page. You can find out about the programs of the European Union and about different webinars and business opportunities and things like that. So the question is, where do I start? Yeah, and this presentation won't go into any kind of depth here because I don't have too much time to tell you all about this stuff, but it should hopefully take away some of the pain points if you're trying to get started working with Wakeo so that you know where to go with it. So the first thing that you could do, one thing that you could do if you're signed in, I should be signed in, is go to your dashboard. And in the dashboard, you'll see a number of things that you can do. Now, in this dashboard, I'm signed in with the Essential, with the free plan. We do have paid plans if you want to do more, or if you want to have easier data egress, or if you want access to more computing resources. And I won't be showing you that stuff. I'm showing you the vanilla things that you can get just by being a person living on planet Earth. No questions asked, except for these questions. So the first thing that you'll want to do is take a look over here. You see that there are all kinds of things, like you have a tenant where you can spin up cloud instances, you can spin up virtual machines. There's a Jupyter Hub. There's a OneDrive, which is called the Wakeo Drive. There's a place where you can go to talk with people if you're community oriented, and then an application manager in your classic settings. All of that is very useful if you already know what you want to do. I'm not going to go there immediately. Instead, I'm going to go to the data itself, where you have this wonderful view of the world. Now, this is your classic WMS, so you can, I don't have a mouse wheel here, so I'll just use my mouse buttons for this. So you can click in, zoom into things, and just like you're familiar with from other applications, they all load, and you can overlay different things on top of each other. Interestingly, in this view, you see that part of this map is your classic GIS stuff. You have two layers that are layered on top of each other, plus some other layers. One of them could be a base map. So it looks like this, kind of like how the Earth would look without clouds, but that's terrifying, so I turned that off. The other thing I leave turned on is coastline and reference features so that I can orient myself. So those are two layers that are in there by default. And then these things are layered on top. So one of the things that's layered on top is global 10-day normalized difference vegetation index, what geographers and biologists like to call NDVI. It's really important if you're looking at plants. And the other thing is the global 10-day burned area with a resolution of 333 meters. And it says here, this data set cannot be shown on the map, but you can still access the data by downloading it. Now, this applies for all of the data there. So for the entire data collection, and I will show you, we have a terrifyingly high amount of data on Wakeo. For all of that data, you can download it. And if I were to download this data, then it would come onto my laptop via the Wi-Fi. We don't want that to happen because we'd be here a long time. But I want you to be aware of the option. So you can make a selection, you can request the data directly, or you can have it generate you an API request. And that stuff is important because you can steal that API request and use it, for example, in a Jupyter notebook to get the data in a better environment than my laptop. But we'll get to that in a couple seconds. I would just like to show off a little bit some of the data that we have available for you. So opening up the layers, I will try to kill you with data in a couple of minutes, but for the moment, I'm going into these layers that I'm going to add to the map because I think they're very beautiful. So one of them is a global ocean physics analysis and forecast. It's really nice. And you can see even this data set is divided up into 13 plus 5 plus 9 plus 2 plus 3 plus 13 fields. We'll pick our favorite ones. So let's take a look at the sea ice fraction, the sea ice velocity, the sea water velocity, and the seawater salinity I will leave off because we already have enough layers. So here now you see that you have these wonderful model outputs showing the current circulating in the ocean. And And you can see that there are a number of other options that you have here too. So I could have arrows shown so I have not only an idea of the magnitude of the movement of water on the sea surface, but also its direction. And then you can do a couple of other light things, like you can set the transparency for a layer or give it a log scale rather than a linear scale, if that's the kind of things that you want to do. And well, I wish I would have brought my mouse because I'm having trouble zooming out with my mouse pad. But we'll just take a look at it like this. Then you also have things like sea ice velocity in the same layer. So if we go up, then you can see where there are colors, there's sea ice and it's moving. And there's also sea ice fraction, which tells you how much of the sea is occupied by ice. And this you can get straight up here via the WMS. But you can also download the data or get the API call to get that data. What else can we look at? A couple of other nice things I'd like to show you. Something very beautiful is the level 1B Olchi. That is one of the satellites that, or that's one of the instruments and one of the satellites that EUMETSAT flies. So here you see, for an environmental satellite, a pretty high resolution that picks up the colors that it sees when it's looking at the Earth. So now you're not looking at model outputs anymore. So you have annoying things like clouds in the way of seeing the Earth's surface, or if you're into atmosphere, you have the Earth's surface getting in the way of your viewing clouds. It's more of a raw signal because this is an observational product. And then what else do I have? Another very beautiful layer is ocean color. So here you can see some really fascinating ocean swirls when that loads. Here you see the implementation of our tiling. It's so that you're not having to download the entire Earth when looking at it. I'm going to reload the page so that that's forced to reload. And while we wait, and another interesting artifact in this product, because it's an observational product, is that you can observe there are white areas, and these are places where the satellite couldn't see past the clouds. So, so that's pretty cool. Let me get out of here so I can zoom back out. And then just to give you an idea of what else we have, there's chlorophyll concentration, synthetic aperture radar. No, these aren't my favorites. One of my favorites. Sea surface temperature, chlorophyll, and NDVI is one of my favorites again. Now, I picked these because they make for beautiful visualizations, but I'm taking too much time showing them to you, so I'm going to stop doing that now. If you are interested in finding data sets on your own, then all you have to do is either do a free text search, say that you're into leaf area index, then you can search for leaf, and here you have the you have PAR, you got fraction of vegetation cover, all kinds of stuff. These are all the things that have leaf somewhere in their descriptions or titles. And you can further limit that by saying, okay, is this an aerosol product, an atmospheric product? Is this of the past or the future? Is this for Europe or is it global? And what European product was responsible for making this? And you see that there are all kinds of selection criteria here. So you really, really get a lot of data. These here are just categories, but these are the individual data sets. And all of them, or many of them, decompose into somewhere between 5 and 10 further individual data sets, variables within that data set. So that's all really rad if you're wanting to discover data, explore it. And what I've been showing is the map functionality down here. What I have not shown is the fact that you can also go back and forth in time. And this time slider is applying to all the layers that I have loaded. So now, if I want to compare what's going on with the ocean color, at the same time that I'm looking at, say, seawater velocity, then here they are overlaid on top of each other. And I could draw some conclusions, or at least narrow down the search radius of features that I might be looking for in this data. So that's really, really cool. If you want to do actual work with the data, of course, you're not going to be working with a web map service. Instead, you'll want to do something probably with code, either as a script to do kind of batch processing with existing programs, or you might be using my favorite language, which is Python. And for that, we have a lot of examples on our Jupyter Hub. So I go in beginner mode, and now I'm really stressing the system. So hopefully it'll crash on us and we'll see something interesting. What I should have done is start this in the background, because now the server's starting and it's being made and baked fresh for me. I'll tell you a little bit about what's in there first. So on the server, you have things like a bash shell where you can do everything that you would do with bash. And you also have an environment that's already set up for working with Python, plus a number of notebooks and stuff that we tell you how to work. Now, all of the really interesting stuff is in this public area, because there you can find out, well, you can get a welcome to Wikio, which is a notebook, and it'll tell you all about how to find things here, and how to use the APIs and what's covered by what. And this has some really interesting case studies. So if you're interested in machine learning, say, and you're wanting to do something related to climate or atmosphere, then we can look at machine learning for floods as an example. And here I have some, oh gee, I picked a bad example. Let me go back up a little bit. I wanted something where it's easy to find the notebook itself. I go back to, let's go to atmosphere. And here's a Wikio webinar. And then I have a number of notebooks. So here, this is all stuff that's related to the Sentinel-5P mission that looks at nitrate in O2. And you can see basically the structuring of the notebook and then runnable examples and their results. And in the interest of time, I'm not going to run these for you. Now, if you're working with the free version of Wikio, be warned, you do not have computing resources beyond what's in this little tiny server here. So basically, you could download the notebooks and then use them on your own machine. If you go with a paid plan, then you can do more. You have a little bit of processing here, but it's really not much. And this public stuff is in a, it's on a read-only drive. So what you have to do is make a copy of it in your own writable area. So for that, you'd have to either use the GUI to create folders and files, or just open up a terminal and start hacking on it, like I am wont to do. So, and with that, I'm a bit over time. I'm going to plug a couple of other things. Again, if you want to store data on Wikio, there's the Wikio drive, and what's probably most interesting for everybody, because we're all modern people, is working with the tenant so that you can spin up your own classic cloud resources. So you see, there's tons of data on there and tons of computing resources if you want to use them. You don't have to. You can also download the data to a cloud if you want. And you've seen in the previous talk some examples of what you can do with it. So my question to you would be, what are you going to do with Wikio? And that's my talk.
Daniel, thank you very much. Okay, so this mic is much more better. Are there any questions? Just a few questions, 1 or 2 questions, and we can leave basically you after we are done with the talks, with the demo. So if there will be people interested, so they can approach you. And
I'll still be around, yeah.
We will leave it on the beamer. Yeah. So are there any questions? One.
Hello. Oh, okay, let's see. I'm not gonna shout. I'm gonna thank you for the talk, and I have a question. So the question is, who are main users of this platform? I can imagine that it could be very interesting for the researchers that do research, environment research, and potentially this data could be super useful for them. Potentially, maybe some startups could use it to start some new business, or at least to check the idea, and maybe later they use an API to download the data or something. What would you say?
Well, as I've shown tonight, this is more a data discovery platform. That is not the real primary use case for Wikio, because what Wikio has is a ton of different data, all related to different aspects of the environment, collected by a lot of different major environmental programs. Copernicus, which is the program that produces the data that goes onto Wikio, is the biggest environmental data collection program in history. So lots and lots of disciplines are covered, from land cover management to pollution detection to to flood forecasting, fire detection, and everything you can think of related to the ocean. I've done a lot of ocean stuff because I had ocean on my mind following the previous talk, but there's just as many atmospheric and land applications in there. All that data is really interesting when you start to combine it across disciplines. And working with data is really efficient when you're not moving the data around a lot. So if you're wanting to use the web portal to find data, then yes, you can use it for that, and you can download it and then put it into your environment. But I think the more interesting use cases are when people are moving into the cloud and using, and with the cloud, I mean the Wakeo cloud, using that as the compute platform, because that's where you can be very data proximate as compared to always doing ETL to put your data somewhere else. Our primary users, so I'm from UMetSat, we contributed a lot to Wakeo, and our primary users in the past were always national weather services, like the Deutsche Wetterdienst, for example. And they already have data access mechanisms that pull down all the data that they need from us. They're very focused on certain environmental tasks. Wakeo is interesting because it's much easier to synthesize new use cases out of the variety of data that we have there. So I think for startups, this is a really, really big potential because of the amount of free data to be had there.
If I may, I would like to give an orientation on that. Can you hear me? Yeah. So for us, for example, it's critical in the case of the one wave, also the tsunami verification, because the access to the data is very important for us. And we are the closest possible to the source of the data. Then this is what we have to be in the Wakeo, because the data is there. You are not going to have this data quicker in any other place.
And the data holdings aren't static either. They're updated continually as it's produced from space or from models.
Okay, more questions? Maybe one more question. Yeah.
Just maybe a quick one. Thank you very much. You just mentioned it already, but how exactly is the data set? Is the data set formed? Like how often are the updates happening, and how is it structured?
Oh, well, that's a complex question. It's more complex than you'd think because the data sources are really disparate. So you have model data that comes out of forecast models that comes in at fairly regular intervals. Then you have data that comes down from space. And there it depends on the space-to-ground downlink and the orbit of the spacecraft, plus the availability of ground stations and stuff like that. So what that means in practice is that individual data sets have individual timeliness requirements, and they're all written down somewhere, but I don't have them in my head. Sorry.
Okay, thank you.
Okay, Daniel, so thank you very much. It was a cool demo. Yeah, so we already have seen today use cases, what could be done with this kind of data. And we have also seen the tech stack. So in this case, it's Wakeo, so how it's possible to do today. And there is one more talk we have today, one more announcement, which basically summarizes all those things like the use case and also the data and basically the environment which could be used, and everyone basically can start playing around with that. And actually there is a brand new course online where there is a chance for everyone just start doing stuff with this kind of data. And we have today Neil Fletcher, who is a digital media and outreach manager at UMetSat. And before he will go on the stage, so we would like to show you a very short video.
Hi.
Hello and welcome to this course on artificial intelligence for Earth monitoring. I'm Dallas Campbell, and I'm going to take you through this course as you discover how cutting-edge artificial intelligence and machine learning technologies are helping to advance Earth observation science and the benefits that this has for citizens. The course will provide you with an overview of the different types of AI and ML and the fundamental techniques of working with AI algorithms for analysing satellite-based Earth observations and in situ data. You'll also be able to work with hands-on tutorials using Jupyter notebooks so you can see for yourself how AI works. We're going to cover 4 thematic areas, so oceans, atmosphere, land and climate. And in each of these topics, you'll be learning from experts who use AI to discover more about Earth and to solve some of the fundamental problems that we face as a society. This is a Copernicus course developed by EUMETSAT in partnership with ECMWF, Mercator Ocean International and the European Environment Agency. We look forward to seeing you on the course.
Okay, right. It's really good to be here, and thanks for the intro, Eldar. I'll just jump over this one. I mean, I work for EUMETSAT in Darmstadt, same as Daniel as well. So we've just seen the course trailer for the MOOC on AI and Earth monitoring, and it's a Copernicus-focused course. And the idea is to kind of really introduce people to Copernicus data in the same way that Daniel's just been doing, showing you on Vecchio. We wanted to kind of set up a massive open online course that really kind of brings people in and shows people what kind of data is available, but then also go the extra step of actually providing Jupyter notebooks with Python code and machine learning examples to help people connect the different types of data together with machine learning techniques. So that's why we've basically set this MOOC up. And the whole course structure, I'll just tell you a little bit more detail about it than the trailer. The course structure is it's supposed to be over 6 weeks. It's structured to be 6 weeks, but you can basically go in and access all the content straight away. You don't have to do it week by week. And the estimate is 3 or 4 hours a week. And it covers, you can just see the syllabus there. It covers Copernicus and AI, and then all the themes of atmosphere, land, oceans, and climate. So there's a big range of content in there for people. I think what is really good with it is we've got over 40 individual contributors on the course. So it's a real wide range of people involved with it, and there's more than 50 videos. And we're actually hosting the course on the FutureLearn platform, where there's about 13 million users. So you've already got a lot of people joining up with the course. And then we're putting the practical Jupyter notebooks are all on the Vecchio platform. So if you want to register for the course, you basically go to FutureLearn and register there. And then you need to register on Vecchio for the coding side of it. And you'll find it's a mixture of video and interactive content. And one of the really good things that's new, I think, is that we've got all these notebooks there that people can use and work on. And actually, the course started on Monday, and we've had, I think it's the latest number is about 5,800 people have signed up for it. And so there's absolutely loads of people going on and using the notebooks and looking at the videos. And what's really nice about it is that on the forum, you get people talking and asking questions, and then other people are answering for them and helping them out. And you get a bit of a community feel. And we're going to organize bi-weekly streamed question and answer sessions as well to kind of make it feel a bit more like a course for people, even though it's obviously all online. And the other thing I would say is with the notebooks, sometimes I find when I look at notebooks, things don't work and I have problems and I think, what does that do? How does that work? And what we've done with each of the notebooks is we've done a tutorial video. So somebody actually goes through the notebooks and explains everything to show you how it all works. And so just to show you what you'll see when you're on the course, this example is, I've got week 3, which is about land, and week 4 about the oceans on the right. And you see it's basically video content talking about people showing how they're using machine learning with Copernicus data and the different initiatives that are being developed. And then also we've got Jupyter notebooks that are linked where you can actually see, you can kind of go in and really start to work with the data, which I think is cool because it kind of brings it to life a bit. And so we've got the land and then we've got the oceans. And again, we've got the notebooks cover things like land cover and looking at vegetation change over time or ship classification. So if you're interested in those kind of topics, there's a good range of content to look at there. And then finally, yeah, just to say, yeah, if you're interested in AI and machine learning and Earth monitoring, please feel free to join the course. That's the link to it. And you'll join about 5,000, nearly 6,000 people who are already on it. So I hope you find it useful if you join.
Thank you.
Yeah.
Yeah. Thank you very much, Neil, for sharing. Are there any questions regarding the course? You have, yeah.
Just a quick one, won't be long, promise. Quick question. So I assume it's in Python, right?
Yes, yeah.
So how advanced does the Python knowledge have to be when you start the course?
I think I think there's 2 users really for the course. There's people who want to come in and just learn a bit about machine learning and AI and how people are using it with Earth observation data. And then for the notebooks, I think you need some background with Python because some of them are quite detailed and technical. So yeah, so they're not kind of, I would say, beginner notebooks, but everything is very well explained because that's the whole idea, that you can kind of work your way through it.
Okay, thank you.
Yeah.
Someone else? Okay, cool. So thank you very much, Neil, once again for sharing.
No problem.
And I know about this course because I registered. I just started it, and I should say there was really a lot of effort invested. So it's not a kind of course that you record at home with and then you share the screen. So it's really a lot of effort was invested there. So thank you.
Yep. Cool.
And I would just would like to say that if you have still questions or new questions just came to your mind, feel free to talk with the guys, with Daniel, Neil, and Mario. So they're all here. And now we have socializing, and that was basically the idea of keep the talks part short today, but enjoy really the socializing. So we have also pizza, but I did really one fuck up today, and this I think the only one I did. The rest worked really well. I ordered the pizza 1 hour earlier, so it's there, but it's not really that hot. So I hope that you will excuse me for that. Usually everything was good. Yeah. Yeah. So just enjoy the rest of the evening. So we have actually like open end, so you can stay longer, no problem. Yeah, and I would like also to thank the speakers, of course, Daniel, Mario, Neil. Thanks for coming and sharing the work that you are doing. And thanks for the people on the YouTube. We had also a few questions there. Yeah, so that's it for today. Thank you very much.